Alright, this is lesson 3.7, or section 3.7. We're skipping 3.4, 3.5, and 3.6, going right over to 3.7. It's solving rational equations. Now, we've already learned in 3.1 or 3.2 or 3.3 how to multiply rational equations together like this, or how to add two rational equations, or subtract, or expressions, subtract them. We've also learned how to divide them. So this section deals with equations where we have to solve and find out what x equals. It really isn't that hard. These are very, very easy to do for the most part. So there's some steps over here. Step 1 is to make all denominators the same. You want every denominator to have a common, or to be the same. In this case, for this example, they already are. We have an x plus 2 over here and an x plus 2 over here. So we really don't need to make all denominators the same on this problem. But sometimes you are going to have to get them to be the same. And the reason that's important is because if I took this fraction over here and this fraction over here, as long as you multiply both sides of an equation by the same thing, it doesn't matter what you multiply it by, as long as it's the same. So if I multiply it by x plus 2 over here and by x plus 2 over here, then that's going to cancel the denominators. And so we're no longer really solving a rational equation anymore. All we're really solving is the equation that's left over in the numerator, which is x minus 1 equals x squared plus 2x minus 3. So that's step 2. Once you've made sure that all denominators are the same, step 2 is to solve the equation in the numerator, which is this one right here. Alright, now we're recording.
Hello. Has anybody gone anywhere on this one? What are we even doing here? How do we solve this? The one in blue, I'm talking about the one in blue.
Get everything on the same side, is that what you're saying? Subtract x, and I would actually add the one over here, like that. Why? What is that? To get one side equal to 0? And what? Say that. That's cute, I suppose. But if we get one side equal to 0, then we can factor it.
Hey, didn't we just practice this on the quiz?
No.
Yeah. Oh, man. So you guys are totally prepared for this now, aren't you?
I know the answer.
What do you think it is?
Oh,
What'd you get?
I'm pretty sure it's x plus 3 equals 0. I think it's probably just 0.
Well, we need to have two factors like this when we factor.
it's 2 and negative 1.
So you got, well, what were the factors you got, Gabby?
I got x minus 1 and x plus 2.
Okay, stop right there. X minus 1 and...
X plus 2.
Yeah, that's what I got.
Now stop. Is that what we're getting? X minus 1, x plus 2?
That's what I got.
Alright then. Keep going, Gabby.
And then I just said that x equals 1 and x equals negative 2.
X equals 1, x equals...
Because when you plug in 1, that would make it 0, and when you plug
Exactly. Exactly. Very good. Now, there is one slight problem. These, I want to see if you guys can come up with this before I just tell you what the problem is. Are you listening carefully? These two numbers right here, these two numbers are solutions to this equation right there. That is true. Okay? Does that necessarily mean that they're solutions to the original equation? I want you to look at the original equation very carefully and look at our two solutions. And can anybody see a problem? And if you can, just keep it to yourself for a second. Keep it to yourself for just a second. But there's kind of a problem here. We didn't do anything wrong. Gabby didn't do anything wrong with the factoring. -2 and +1 are the correct numbers. I'm just curious. Don't yell anything out loud, but just raise of hands. Does anybody think they know what I'm talking about? Okay. You have an idea? What's your idea?
You guys, he's absolutely right.
Everything equals 0.
If x equals -2, and we tried to check that answer right here, for example, -2 plus 2 is 0. You can't divide by 0.
So there is a third step here. Over here on the list of steps. So step 3,
Oh, you kind of blew my mind.
check for good. Excluded values. You remember in lesson 3.1 we had excluded values? X equals -2 would have been an excluded value, so x cannot equal -2. Our only solution is x equals 1. See, these aren't that bad.
That is the last step.
So in these problems, will they ask you for the excluded value? Or will it just...
You have to check for them at the end. You get a couple of answers. Some of them might be excluded. It could have been that both of those worked, so you don't always have the answers that are excluded. Sometimes you do, sometimes you don't.
Like, are you supposed to state it, or do you
Only circle the answer that works. Yep. Sorry, was there a question? Next year when you take pre-calculus, if you're going to take pre-calculus, you learn a fancy word for this kind of an answer that's not really an answer. It's called extraneous. Sounds awesome, doesn't it? It's kind of like pre-calculus. So here's one I want you guys to try on your own. If I can figure out how this dang book works. For pre-calculus? No. Pre-calculus is almost exactly like this class.
What the heck? Why do we take it twice?
Ask the state. Email your state legislatures and ask them that. That's what I'm wondering. Also.
They don't.
Here's what I want you guys to try on your own.
They send automated emails. Thank you for your
Oh, this is a super easy one. I'm embarrassed to even give you this question. Try it. Coming right out of your book. And it's a few pages back or a few pages forward. Anyway, write it down. Give it a go. Way easier than what we just did. Yeah.
You got it.
Turn to the person next to you. If you've got an answer, turn to the person next to you, see what happened. Did you check it though for an excluded? Is it an excluded value? Or does it work?
Still works.
What are we getting as an answer? 5. 5? Alright, let's move past these easy ones. What do you think's coming up next?
Super hard.
Well, what's going to make these problems more difficult then? Because right now they're pretty easy.
Other variables.
What if the denominators aren't the same? Right? Well, anyway, the answer here is 5.
Now, I'm not going to be too concerned if you show me the step of multiplying both sides by x minus 2. Really, that's what should happen here. And so you're left with 4 equals x minus 1. Ooh, x minus 1. If you have the same denominator already, you really just got to solve the equation that's left over in the numerator. 4 equals x minus 1. Add the 1, x equals 5. Let's get a little more challenging. You guys look like you're up for a challenge, right? Oh my, here we go. Example 3. This is on page 208. It's the Got It Part B problem. This one, unfortunately,
Is a little more challenging.
or maybe it's fortunately, I don't know. The nice thing is it has the same 3 steps as the problem above it.
What was step 1? Make the denominators equal. If they're not equal, make them equal to each other. Then step 2, once they are equal to each other, you solve what's left in the numerators. Step 3
is to check for excluded values. So here we go. This is new stuff. If you guys aren't paying full attention to this, you're not going to get it. You really aren't. Okay? No distractions. Here we go. This denominator is x plus 1, right? But this one is x plus 4. We talked about this last week. Is this okay to do? Yes or no? Just adding 3?
No.
You sure?
Yes. You have to add x plus 1 to one side and then x plus 4 to the other.
You can't just add something to a fraction. You can multiply something to a fraction. So this fraction needs an x plus 4, doesn't it? But now this fraction has an x plus 4 and it has an x plus 1 in the denominator. So you see which fraction I'm circling right here? What does it need now? This side needs an x plus 1 over x plus 1. And now do you see the fraction I'm circling? What does this fraction need? This one also needs an x plus 1 over x plus 1. All of the denominators have to be exactly the same. Yeah. Did that answer your question? All right. You have blonde? No, I know how you feel. I have them. See? So, if you distribute the x, you're going to get x squared plus 4x over x plus 4 times x plus 1. That's what this fraction turns into. So that louder, Byron, this middle fraction, is that what you're talking about?
Yeah.
What is it?
Plus 12.
It's hard. I didn't write it very well, but that's a 1 right there.
3x plus 1.
3x plus 3 over x plus 4 times x plus 1. And then after the equal sign, we're going to have, ooh, dang it. Be careful here. X squared. Keep going. Plus 4x. Plus 3. Hey, nice. If these are multiplied together correctly, you're going to get x squared plus 4x plus 3 over x plus 4 times x plus 1. Are all of the denominators now the same?
So it took a little bit longer, but we're done with step 1. Step 1 is done. All the denominators are the same. Okay. Now, what's step 2?
So the equation of the numerators.
So all I really would expect you to do at this point is take a look at what you have in the numerators. You have x squared plus 4x plus 3x plus 3 equals x squared plus 4x plus 3. That's a great question. I was just going to ask that, actually. What about combining like terms?
You combine before you move them over.
We could. Which ones would you be talking about?
4x.
4x and 3x. We could turn that into 7x. X squared plus 7x plus 3 equals x squared plus 4x plus, what am I meant? Oh, plus 3. Keep going. What if I minus an x squared on both? Can I do that? All right, x squareds are gone. Whoa. Wait, we're going way too fast here. Hold on.
So 7.
So now we have 7x equals 4x.
Does that make 4?
Subtract 4x. There we go. Subtract 4x.
Nothing.
We have 3x equals 0.
Divide by 3.
Divide by 3. So x equals 0. 0 is a number, isn't it? It's a valid solution. Get her done? Okay. So what's step 3 now? We're not quite done with the process yet. So if we go back up to the original, the one that I have in blue, if I plug in a 0 for any of these x's on the bottom, is that going to be okay? So x equals 0 is not excluded, so there you go. X equals 0. It's the same 3 steps, except step 1 took a little bit longer because we had to make the denominators equal. They weren't already equal to begin with. Yes?
So like when you subtracted the 2x, I mean the x squared and the 3, was that just because there was like an equal sign in the middle?
Well, yeah, you have to do the same thing on both sides because of the equal sign. Is that what you're asking?
Yeah, but like instead of equal sign, if there was like a plus 3 plus x squared, could you still like subtract?
If this was not an equal sign, like
Yeah.
a plus,
Yeah.
then you would combine them together.
Oh, okay.
But since it was an equal sign here, you have to do the opposite on both sides.
Okay.
That one I would say is a little challenging. Here's an easier one for you to practice. Here's an example. I want you to try this one if you can on your lonesome. Or try to get as far as you can get. It's 5x divided by 4 minus 3 over x is equal to 1 over 4. This one I think is a little bit easier. Try it on your own.
Using the same 3 steps. Get all the denominators the same. And then you solve what's left in the numerator.
Thank you. Are you finished, right?
if you've done this correctly, hopefully you're to a point where you have a quadratic that doesn't factor. Am I right? 5x squared minus x minus 12. Now I'll show how to get that in just a second, but I want to. You guys know what to do, but I don't think you know that you know what to do. What do you do if you have a quadratic that doesn't factor? The quadratic formula. Right? So if you think you can handle it now, maybe try the quadratic formula. If you need to, Trevor will sing the song for you. Right? No? Or maybe you. Or that Trevor? You'll sing it for me? We'll have a duet. You'll sing bass. You got soprano.
I think Hop could do a one-man choir.
A one-man choir?
Yeah, go ahead and press ups.
No.
What's that?
Waiting for you to do the dang quadratic formula. Welcome back. So you should be getting to a point in this problem where you have to use the quadratic formula. So it's the opposite of b plus minus the square of b squared minus 4ac.
All over.
7.
So I might have lied to you. This one, I would say this one still is rather challenging. Let's go through this real slow. This is the level of problem, you guys, that you can expect on the test. So now do I have your full attention, right? What does this, do you see the fraction I'm circling up on the screen? What does it need in the denominator that the other ones have? You see how there's an x right here? But there's no x over here. So this side needs an x over x. But now this denominator is 4x. So what does this right here need?
Times by 4.
This side needs a 4 over 4. So now it's a 4x.
Yes.
This side here needs an x over x. So now that's 4x as well. All of the denominators are 4x.
Yes.
So all we need to do now, once the denominators are the same, is to solve the equation that's left over in the numerator. So it's 5x squared minus 12 equals x. Now what? Yep, subtract the x. We have 5x squared minus x minus 12. And I hope some of you tried to factor, but then you find out it doesn't factor, right? So that doesn't mean you put your pencil down and give up. You persevere with the quadratic formula that you guys are all expert at. X equals opposite of b plus or minus the square root.
B squared minus 4.
Ooh, that was good. B squared minus. You should join the choir. 4ac. Wow, what's wrong with the choir?
Math choir?
You disinquire?
Not me, he said that.
Mason, you disinquire?
No, I said math choir.
Oh, math choir. All right.
Oh, you probably said math choir.
Anyway, what's the opposite of b? Positive 1. Yep, plus or minus. B squared is negative 1 squared, which is 1 minus 4 times 5 times negative 12 all over 2 times 5. See, this isn't that bad. What you guys had for lunch is probably worse than this. So this isn't that bad.
lunch is always bad.
What do we get underneath the square root? 1 plus or minus?
41.
Ooh, I'm hearing a couple of different numbers.
I'd rather go with upchuck.
Here's what I would suggest. I've made this suggestion before. I don't know why you guys don't always do this. Use your dang old calculators. 1 minus 4, parenthesis 5, parenthesis negative 12. Your calculator's not going to lie to you.
Really?
It's 241. All over 10. 2a, which turns out to be 10. Okay. Here's what I'm assuming your homework is going to want, because this is what it does in the book. And this is, we haven't done this yet up until this point, and I don't think you did last year either, so you're going to want to watch this, because you know how picky your online homework is, right?
Yes.
This is just according to what the book looks like. This is what I think they're going to want you to do. So get your calculators out. You need to know how to do this on a calculator. You ready? Otherwise, you are going to have a headache on this homework because it's not going to accept your answers unless you type it in like this. Okay? They're going to want the decimal form of this. So, type in what I'm typing. 1 plus square root of 241. Hit enter. And then divide that by 10. The square root is second and then x squared. So one of your answers is approximately 1.65. X is approximately 1.65. That's what the squiggly line means.
I used to like that too.
What? Or it's bacon.
Is there a squiggly line in the computer?
Yeah.
What?
They'll put it on there for you. They'll say X.
Like,
Now, how do we get the other? There's two answers here, guys. How do we get the other one? 1 minus square root 2. You guys do that on your own. Don't watch me. Go do it. Do 1 minus
Wait, what is the squiggly name?
approximately, because I had to round, right?
Oh.
Whenever you round, it's an approximation.
So this is how our computer does it?
I'm pretty sure. I'll look before the bell rings. I'll make sure.
But you're supposed to have the ground.
What did we get?
X is approximately, say that again, negative 1.45. Now, Abby, that's a good question. Say that louder. No, say it louder. Okay, that's a good question. Man, this is messy. But if you go back to the original problem, the only issue you would ever have is with that denominator right there. And what's the only excluded value for that denominator? X can't be 0. And since none of these are 0, both of them are good. Does that answer your question? Okay.
And if it is 0, then it's undefined.
Then it wouldn't have been a solution. Yep.
Are we having fun yet?
No, I do it all wrong.
I'm having a blast. Okay. Let's keep. Actually, I'm going to pause. Let's try another one. 5. This is practice A out of your book. Question 2, practice A, on page 209.
Oh no, the story.
No, it's
Oh yeah. We're not.
It's question 2 at the very top of 209. You see what I'm talking about?
Okay.
The 5 over 2x. Isn't that the one? Page 209?
Yeah.
I know. The way they number these is pretty weird. So it's the same idea. So same 3 steps over and over again. You get all the denominators to be the same.
Just more repetition makes this easier. See what you can get to. Try it. Make every single denominator exactly the same. Go. Needs to be exactly the same. Well, I want to make sure you guys have started this the easy way. I'm afraid some of you might have done this the hard way.
Oh, I know.
Does this need to be multiplied by 6?
No.
No, just by 2.
Just by 2 to make it equal to 6. And then it needs another x, right? That's the easy way. I wouldn't do this the hard way. Just multiply it by what it needs.
Just multiply by 2x.
2x, yeah.
Why would you stop something?
Why are we working in the dark?
Because I like the dark. Oh my god.
You guys gonna be a little scared next time you're in an elevator?
I'll just get the heck out.
I guess next time you're in a Brazilian elevator.
What is the beat?
I remember sorry.
Alright, I got my numerators all set.
Okay, I want you guys to get in a small little group around you and see what happened with this problem.
There's one with the top. Like that, just like tops out. They love the see what people around you got. Look at you, man. Now over Yale.
What's happening over here?
No. You get 14 experts. Yeah, I think that would work, so actually move on. Let's call yeah, it sounds like it would be actually
The eyebrows.
What? Let's just say that I got something different. Okay. So you know that once you're done, the top of the numerator is 15 minus 4x equals 6 plus 5x, right? So what I did... Huh? Okay, so what I did was I did plus 4x to both sides, so then it's 9x, and then minus 6 on both sides, so then it'll be 9 equals 9x. So you divide by 9 on each side, and it'll be x equals 1.
Yeah.
You are welcome. No, you're so funny.
Did we have to use quadratic formula?
No.
I don't think we have to last one.
You gotta go back to physics.
Nope. Unless you're an overachiever.
I don't feel like transferring into
Well, second semester, I'll probably be think it's zoology that. At least it's not play beer. I mean, zoology is only a semester. Or if I could switch, I'm trying to switch some of my classes around so I might. I mean, I can make pancakes, eggs, and cereal.
I also know how to bake.
Wait, am I wrong? Oh, actually,
Okay. That's it. Who's gonna make it come up here to the board? Oh, who came up last time? Was it a girl or a boy? I can't remember. You the last one? All right, it's girl's turn. Go ahead. Hey, listen. Let me see here. So, listen. There you go. Hey, just stop for just a second. You're absolutely right. You guys check your papers. Make sure. 3 over 3 to make that a 6x?
yeah.
2x over 2x to make that a 6x, right?
Yes.
That's 6 over 6 to make that, and that's x over x to make that a 6x.
Yeah.
So all the denominators now are 6x. Okay, go on. So you got 15 over 6x. Okay. Minus 4x over 6x equals. Good. You multiply everything by 6. All right. Hey.
I got that in there too.
So negative 4x plus 15 equals.
5x plus 6.
You guys are starting to lose it. Focus. Add 4x. Scoot it down. There you go. Nine equals 9x. Okay. X equals 1. 1 equals it.
Yeah.
Now, we're skipping step 3 though. Is that excluded value? What do you think, Abby?
No.
If I plugged in a 1 for that x, is that okay? Or that x?
Oh, no.
It's okay. What can't you have on the bottom? You can't have a 0, so those are okay. All right. That's it, you guys.